For the first talk of today, it is my pleasure to have Brent. Yeah, most of you know Brent from his work on diagrams and his work on Swarm. Yeah, a Haskell game. Nice. Today, I mean, when Brent told me about what he was planning to do, I was thinking, oh wow, this is something quite new. So he will be talking to us about Haskell for competitive programming. There will also be a little bit of a programming competition, I guess, in the second half of today. Yeah, so let's not make this a bloodbath. Yeah, please, Brent. You can take it for questions.
So when I say competitive programming, how many people, like, I think I know what you're talking about, what that means? Okay, so a bunch of people. All right. So I'm not going to try to give a formal definition, but just to make sure we're on the same page, kind of a flavor of what we're talking about. So typically, there's some kind of well-specified input and a specification of what output you should have for some input, right? And your job is to write a program that transforms input in the given format to the correct output. And you submit the program, which is run on a bunch of secret test inputs and make sure that you get the right answer on all of them. Typically, there's some kind of time pressure, right? Either there's a time limit on how long your program is allowed to run, and of course, some kind of overall, like you have to write it in a certain amount of time, or you want to try to write it as fast as possible. You can also do it without the time pressure, like I would call recreational competitive programming. If you're just like, I'm just trying to solve some fun problems, and I enjoy doing that. So that setup creates a few strange incentives. So we definitely want to optimize for time. I said there's usually some kind of time pressure. Right? Optimize for how long it takes you to write the program, how fast the program runs. Obviously, correctness, you want it to be correct, and ease of debugging, because of course, typically, you would write a program and you submit it and it says wrong. And you're like, well, now I got to figure out what's wrong. But there's some other things that we don't want to optimize for. For example, maintainability. We're going to write this program, and once it says accepted, we're done. We're never going to touch that program again, probably, right? Robustness. We are guaranteed that the inputs will be exactly as specified. We do not need to handle other types of inputs or exceptional circumstances or whatever. So you'll see this come up later, where the style of code that we tend to write is very different than what you would typically think of as sort of best practices. So there's a ton of sites where you can do this. One of my favorites is called Caddis, but this is probably not even a complete list. And I'll show you Caddis in a minute. A few resources are also linked in the Discord, the competitive programming channel in Discord, where I have a repository of a bunch of my Haskell code for competitive programming, and I've written a bunch of blog posts about it. And so let's just do a demo. So as Farhad said, there's going to be I've organized a little contest for you all. So the second half. So it will start at 10:30 precisely. Whether no matter what I do, I've set it up to start at 10:30. So if you want to participate in that, I would welcome you all to participate. And if you want to, while I'm talking, if you want to go and sign up and make sure that you're all registered and ready to go, you can definitely do that. It's linked in the competitive programming Discord channel. But I'll link to it at the end. And you can just sign up right when the contest starts. It's not a big deal. But if you were like, I want to maximize it's only a 30-minute contest, right? So if you want to maximize your time, you can get signed up. And I would encourage you. You can be by yourself or with some friends. Just one computer per team. But I would encourage you to work with other people. Either if you have a friend or if you're just sitting next to someone that you don't know, you're just like, hey, let's do this together. All right. So in the next 20 minutes, I don't know if we'll get through all three of these, but I've picked 3 problems that I'm going to sort of live code solutions for you so you can kind of see how this works. And I want to show off some of the cool benefits of functional programming in general and Haskell in particular for doing these kinds of problems. So here's the first problem. And usually there's some kind of long-winded, silly story, so we're going to skip that. But basically, to save time, I'll just tell you, right? So here's the input specification. There's a number that tells us how many numbers there are going to be. And then each number like 212, we're supposed to interpret that as 21 squared. So we always take the last digit and make it an exponent, and then we just add them all up. So this number is supposed to be, 21 squared plus 125 cubed. And that's it. So this is a pretty easy one. But let's see how we're going to solve this. So, I've got a script that will, generate a template and download all the sample inputs and outputs and stuff. But okay. So, spoiler alert. Thinking back to that slide that I showed first that said, oh, there's some input, and then you write a program and it produces some output. That looks a lot like a function, right? But we have to do we have to read in the, the input, do all this I/O. We have to read line this and print line that, and it's annoying. But there's this magical function called interact, and the type of interact. If you haven't seen this before, interact says, you give me a function from string to string, and then I'll return an I/O action. What does that I/O action do? It will read from standard input, pass standard input to your function, and then whatever your function outputs, it prints that to standard output. Moreover, it does it using lazy I/O, so it actually streams. When your function demands more input, it does more I/O to read more of it, right? This is deeply magical and unsafe and terrible and perfect. So you should never use, this is one of those things where you should never ever use interact in any kind of real world program, but for competitive programming, it's exactly what we want. So this is the only I/O that we're ever gonna do. That's it, we're done with I/O. Now we're just writing a pure function that transforms the input to the output. So, let's see, how are we gonna do that? Well, I guess we should first split it up into lines. And by the way, again, this is something I typically don't do when I'm writing, real programs, but I just like writing from left to right while I'm thinking about transforming the input to output. And so I use this, it's a backwards function composition operator from control.category. And all right, so we're going to split into lines. This first number tells us how many numbers they're going to be. We don't care because it's just going to read to the end of standard input, and then we just get a list of things. We don't need to know how many there are, so we'll drop that. And by the way, if there's questions, feel free to interrupt. That may affect how many things we can get through, but that's okay. I'd rather answer burning questions than just talk at you for a long time. So. And now we're going to, I guess we should we'll read each of them, turn them into integers, and then, actually we'll read them, and then each one will, process it, by splitting off the last digit and doing the exponent thing. And then we're gonna, once we do that, we're gonna sum them all up, and then we're gonna turn that back into a string, and that's it. And then our process function, we'll just say integer to integer. Probably in this problem, int is going to be big enough. And int is definitely faster if you really care about squeezing out performance, but integer is much safer. We don't have to worry about overflows. So, process n is just, we're going to do n div 10 to the power of n mod 10. That's it. So hopefully that is a complete and correct. So I have a little script that will test it on the sample inputs and outputs. Okay, so at least we know it works on the samples that we were given. That doesn't guarantee that it's correct because it's going to be tested on a bunch of other secret test cases, and if we missed some corner case or something. Okay, so the way we do this, there's a few different ways we can do this. So, you can just say start coding, and there it'll open up a little editor that you can paste your code into. Or you can just say upload files and, whoops. I actually have a script that will upload it for me, but I'm not doing that because I want to show you what you will have to do during the contest. So, all right, there it is. And so we say submit, and then we wait and we cross our fingers. So it's running all the test cases, And woohoo, all right. So we solved that one. So if you get the green check mark that says accepted, you are good, right? The alternative would be like, it might have some green checks and then it would have a little red X and it would just say wrong. And you're not told, if it's wrong, it doesn't tell you like, oh, here's the test case it failed on. It just says, yeah, there's some secret test case where your program gave the incorrect answer. Go think about it some more, which is part of the fun, I guess. Well, fun would be one word for it, I guess. Depends on your point of view. All right, so here's another problem. How are we doing on time? We're good, yeah. So here we have, so again, I won't read this whole thing to you, but we're given a bunch of shopping lists. This first number is how many shopping lists there are, and this second number is how many items are in each shopping list. Again, we actually are not going to care about those. We can just throw those away because we can just read in the lines. And then we're supposed to find all the items that occur in every shopping list. So like bread is one of them because it occurs in every single one of these lists, and carrots also occurs in all the lists. And then we're just supposed to print out, how many items there were that were on all the shopping lists, and then print out those items sorted in alphabetical order. Okay? So let's see how we're going to solve this. Shopping list. Shopping list. All right, so let's, oops. All right, same kind of deal. So we're gonna say interact, we're gonna do lines, drop one, we don't care about that first line. And then for each of those lines, we're gonna say, map words to split the line into a bunch of words. And so Haskell has a bunch of course, standard data types. So the containers library is like in the environment where Caddis is gonna run your thing. There's not a lot of libraries that it has, but some standard ones. So we can definitely, sets seem useful for this, right? So if we can make each of these shopping lists into a set, we can just like intersect all of them to find the set of things that are in all, and of course then it'll already be sorted. Yeah, question? We're gonna use ordered sets. So what was your? Why does unordered, so the question is about ordered versus unordered sets. So why would an unordered set seem more appropriate here? Oh, for like a hash set or something. Oh, yeah. That's a good question. Data.set is pretty fast. There's very few problems I've encountered where data.set was not fast enough. And this is not a very hard problem. The time limit is not going to be an issue here. Like with big O versus, and if you see the shopping list, we only have up to 100 shopping lists, and each one has up to 5,000 items, so they're not that big. Yeah, good question though. And actually, I think the unordered containers package is not in the judging environment, so we can't use that, unfortunately. Yeah, question. Yeah, no, and right. Ordered sets is nice here because we need the output to be in alphabetical order. So if we just have it in an ordered set and we just say turn it into a list, it'll be sorted. Yeah. Well, free in terms of we don't have to write code to do it. Yeah.
How do we find out?
You just try them and see if you get a compile error. Sadly, I wish there was a better answer, but I don't have a better answer for you. And in fact, they recently upgraded to a newer version of GHC, which was nice, but at the same time, there were several packages that used to be there that aren't anymore. And I pleaded with them to put them back, and they were like, no, sorry, we can't, specially support, each language. But anyway, oh well. All right, so we're gonna turn each one into a bunch of words, and we're gonna say we have to import data.set qualified as S. Oh, we probably need to say import qualified post, import. All right, and then we'll make it into a set, and then we're going to take that. We now have a list of sets, and we're going to do something like fold r1 s.intersection, which will just intersect all of them, and then we'll say I guess we need to say something like, we'll make show s.size, it'll show the size, and then we'll just convert the set to a list, and then we'll finally do unlines. And let's try this out. Okay, and if we submit this, okay, I'm actually going to use my script. It'll be faster. So we're going to, no, all right. And then, oh, I guess that's the downside. All right. Okay. We got a time limit exceeded error. What happened? So the problem is string is very slow, extremely slow. So and it turns out if you think about like how long each of these items can be and how many items there is, actually, it could be quite a lot of input that we have to read into a bunch of strings, and then we're like making sets of strings, and we're doing lots of string comparisons, and it's very slow. So we really just want to use ByteString instead of string. And this is another one of those places where, so I'm going to use lazy ByteStrings. Not only am I going to use lazy ByteStrings, I'm going to use, you've probably never seen this module before, because you should never ever use this module. This is super terrible. It just assumes that every byte is a single character. So forget Unicode. This is just pure ASCII. Again, in this context, though, we're guaranteed the input is definitely going to be ASCII. And the nice thing about using this is we now get to work with, chars and stuff. So this is going to be qualified as BS, and then we're going to say, all right, we'll do this is now ByteString. This is now ByteStrings. And then we have to say, like, we have to pack this, and then we have to use that. All right. So now everything should be with ByteStrings, and we can test it again to make sure that still works. That still works. So we're going to submit again, and then we'll hopefully be fast enough now.
How come
Yeah.
we didn't use text?
Text. Because that would be more annoying, because I don't know. No, I mean, text is great because it handles Unicode properly and all that stuff, and we don't care. I mean, I think, I haven't tried using text. It probably would be much faster than string, just like ByteString, but ByteString seems like, ByteString char 8 seems simpler and probably marginally faster because it's not even worrying about doing any Unicode conversions, so. Yeah, it's icky. I agree. Again, you should never ever use this unless you're doing competitive programming, right? The incentives are all different. All right. Cool. That worked. How much time do we have? We have 6 minutes. All right. I don't know. We'll see if we can get through the other one. We'll try. I at least want to show it to you because so here we have, I probably might, I'll just talk through how I would solve this. I think I'm not going to quite have time to live code a solution for you, but so the previous one we did, I like it showed off, the use of things like sets and this idea of sort of whole-meal programming, where we just take the input and we just think about transforming it through stages, where we're not doing looping over things and thinking about individual elements. We're just saying, like, I have a list, and I have a list of sets, and I intersect them all, and we're doing stuff at this very high level. And when you can do that, that's really, really nice. And you end up with a lot of, like, one-line solutions to things that would be, at least 20 lines in an imperative language. Okay, so this problem shows off another nice thing that I like. And so here we're given, basically there's a choose your own adventure book. And it tells you for each book there's these are the pages on which a specific section starts. And then each section either could be an ending, and either it's a favorable or a catastrophic ending, right? Or there could be some pages where, it says, okay, you have 3 choices you can make. You can either turn to page 21 or turn to page 6 or turn to page 17, right? And so it's sort of this graph of each page could either be a well, it's a tree, right? It might not be a tree actually. I think it's a DAG. It's definitely because like they could like rejoin. You could like say go here, but then both those lead back to the same thing. Where some of them are these leaf nodes and some like are choices. And what you're supposed to calculate is the number of distinct stories that have a good ending. So like the number of distinct paths I could take through the graph that would end me at one of the like good endings instead of the bad endings. So if you think about how you would do this, you kind of want to start at the leaves, right? So a leaf, you're like, okay, I have, if I just started right here, if it's a good ending, then there's one story that starts here and has a good ending. And if it's bad, there's 0, right? But then you can like work your way up. And for each node, you can say, well, if I already know how many stories that would continue from here, right, I can like add those, to get the total number of good stories that start here. And you can kind of work your way up the tree. And then eventually, you've computed the number for the root node, and that would be the answer. And so typically you would think about, well, you have to do some kind of topological sort first, right? You like make some kind of graph data structure, you do a topological sort, and then you like, once you have them in that order, you can like iterate through them in that order and, fill in the numbers, et cetera, using kind of a dynamic programming thing. We don't need to do any of that in Haskell. We can just make like a lazy map that maps each page number to like the number of good stories that start there, and just like define it recursively. And just say, well, like each one, it's just like, you look up the numbers for the nodes that you can get to from there, and you just add them, and that's the definition. And the runtime system will automatically topologically sort it and figure out the right way to fill it in so that it all works, which is really beautiful. But I don't have time to code it for you, so maybe I'll post it later. All right, so the contest is starting in 2 minutes. So the rules, so here's a link up there. There's also a link in the Discord. Only Haskell is allowed. The site doesn't prevent you from submitting other languages, so just, honor system, no Java. No generative AI, and 1 computer per team. So you can work with as many people as you want, but you can only use 1 computer. So you can't just be like, okay, you do this problem, I'll do this problem. You have to share the computer. If you care about the ranking system, this is it. So it's first by number of problems solved, and then the tiebreaker is sort of the total solve time, which is basically the time that it took you to solve the problems plus 20 minutes per incorrect submission. But if you care, whatever. All right, oops. No, don't do that. So here it is. Oh, just happened to go away. All right. 10 seconds. 5, 4, 3, 2, 1, go.
writing additive code the last 3 years.
Yeah.
Interact just blew my mind. Why did
Yeah.
why did I interact?
Exactly.
I was using like unsafe perform IO.
Right, exactly. Well, it uses like unsafe interleave IO under the hood, but which is why it's unsafe. But you can do weird things.
It just feels nice to not write the word unsafe yourself.
Yeah, exactly. Oh yeah. No, it's perfect for
It
this.
is absolutely perfect. It's great. And I should have. I think also like it's exactly as you said. Like I usually do things like using dot, but in this
Right.
case,
Yeah.
turning the left
Yeah.
feels-
Exactly. Yep.
It's how my brain works. So
Yeah, exactly.
I'm definitely going to use those.
Yeah, good.
those tips.
How about I just make it in PDF and then
We have our first problem solved. Woohoo! Yep. Yeah.
Sorry, I have to pick up the next speaker.
Hey.
I just wanted to say, because I made your course and I think it was really well
Oh,
made,
good.
and
Thank
it
you.
was really helpful. So
Great. I'm
I
glad.
just
Yeah, very
wanted to
glad.
say thanks.
Yeah.
And also I took a look at the diagrams,
Yeah.
and I think it's really like, I haven't learned that, but I think if
Right.
I would have a time I could learn them, because
Yeah.
there are tutorials and stuff.
Yeah.
And I only wondered, is it like the purpose of diagrams is only to make good pictures, or like the diagrams, or there is like do they make more, or is just to have a
You
good graphics made?
can, yeah, you can make whatever. It's just a DSL for making vector graphics. So,
Okay.
I mean, I made it because I wanted to make illustrations and diagrams, things, but people have used it to make art and all sorts of things.
Okay.
So yeah, cool. Yeah.
So yeah,
Cool.
I think if I need it, I will learn it.
Yeah, great.
It's also like from educational view, I think it's really well made.
Yeah, thanks. Good. I'm really glad. Yeah.
When I'm using the chart 8,
Yeah.
how do I read? There's no bs.read, is there?
If you want to read and
Never mind, I'll just use strings.
no, there is a read int specifically that's faster. Yeah. Yep. All right, we're about halfway through. We have a very heated contest, it looks like. Depends on who's going to be able to solve problems D and E. I spoke too soon. And that is time. Well done, everyone. Where are the horsemen of Lambdocalypse? Horsemen of Lambdocalypse? They in here? Right there, yeah. So the third place, congratulations. I think you all were the first team to solve 4, but didn't manage to solve a 5th. Powder, Nip, yeah, 2nd place. Very well done. And where's Taneb? Right here, congratulations. The only one to solve all 5 problems. I think you solved the last one like just in the last minute or something, so very well done. I was going to put 4 problems initially, and then I was like, no, I'll put 5 just to make sure that like no one can solve all of them. But I'm glad I did put a 5th because that seemed to be the right number. Anyway, hopefully you had fun. That was very well done to everyone who participated, and I'm happy. I think we have time for a few questions, right? If anyone has questions, so.
Yeah, that's correct. Thank you very much, Brent. Let me just start with a question that's on everyone's minds, I guess. The ICFP programming contest. Mm-hmm. What would it take for Haskell to get first place?
I mean, I don't think there's any. I don't think the language is. I think usually what ends up happening is that there's the people that win are people who like do this kind of thing a lot. And it doesn't really matter really what language they use. If they're comfortable with the language and they've done this a ton, then they're the ones that end up winning. So,
cool. Thanks. Yeah. I saw a hand somewhere. Yeah, cool.
Yep.
Oh, wait.
I didn't understand the lucky numbers.
The lucky number? Oh,
Yeah,
the problem?
The description, yeah, the K from 1 to...
Oh, yeah, that one had a particularly silly description. All these equations here mean nothing. You can ignore those. And you're just looking for how many numbers there are where, for each K, the first K digits are divisible by K. And so you kind of have to count those, but you can't just list all the numbers and filter and count because there's too many, right? But you have to kind of build them up incrementally. Yeah.
Even if there are for 3 digits.
Right. Then the first digit has to be divisible by 1, which could be anything. The first 2 digits together have to be divisible by 2. And then all three, like the whole number has to be a multiple of 3, I think. Yeah, it's an and. Yeah. I think it says and, right? Yeah. All right, cool. Other questions? Yeah.
Where are you?
Oh, sorry. Sorry, maybe I'm not supposed to be pointing out people. I'll let you all do that.
Do you have like a little parser combinator library implementation saved that you just always copy into your solution?
Yeah, I do, and it's in that the GitHub repository that's linked. I have a little like scanner library. It's a little parser combinator. It doesn't have backtracking at all. There's no alternative instance, but it just. But there's a few things like, for example, you'll notice there's often in problems it says first there's going to be a number, and then after that there's this many things. So I have a combinator called number of that takes a parser and just reads the number and then runs the parser that many times. There's a few things like that specifically for this kind of thing. And you're welcome, all that code on GitHub you're welcome to use, on your own if you want.
What are your feelings on golf? So I've done a fair bit of this, but I also really love golf where you try to
code golf is really fun.
And Haskell is very fun because you're
it is, yeah. And Caddis is pretty good for. So it actually has. I don't know if you can see it on these ones. If we look at statistics, I think it may be, this is maybe only showing us statistics for, this is all the statistics. So if you look at the statistics for a problem, it'll show you not the fastest solutions, it also shows you the shortest. Now, unfortunately, this person, they've figured out there's some kind of loophole in Caddis where you can submit a bash program that maybe like calls out to something else that doesn't get counted, and so it's always 5. So you can just ignore that, but it is fun to try to get your solutions as small as possible. That's fun too.
Can we see those?
Can we? What was that? No, they're secret. You can't. Yeah, you can't see other people's submissions. Not on this site, at least. There might be other sites where you can. Yeah.
What are some language extensions you can recommend that make this sort of thing more efficient?
Language extensions I can recommend. I mean, what was that? View patterns. I use view patterns occasionally. Yeah. I don't know. I mean, honestly, like the kind of code that I write for these tends to be not that fancy, because it takes me longer to think of a fancy solution than to just write a simpler one. So. I tend not to use a ton of, well, I guess you can see, like, if you look in my, if you look in, do I have, I guess I don't have it here. Anyway, I was going to say, if you look in my template, like, there's a bunch of language extensions I have turned on by default, but most of them I don't really use. I just have them there just so I don't have to go, add them every time I use them. Yeah.
Can you reopen the contest so we can still try our solutions even though that's now over?
Oh, that's a good question. Is that... I don't actually... Does it let you... It might... So, okay. You can find these problems. So right now, if I click on this, the URL includes this like contest / whatever / problems. If you just delete this contest / letters, just go to open.caddis.com /problems / whatever, like all these problems are there. And so you can, like I just picked problems that existed on OpenCaddis and just put them in this contest. But it might even let you still submit to the contest. It just you won't show up on the scoreboard. I'm not sure about that, but you can always access them on OpenCaddis itself.
Have you used Haskell in any physical venue where there was a competitive programming challenge going on?
I have not. So I've competed in some online contests that were timed. I've never used it like in an actual contest. So I actually got into this sort of more as a coach. So I have teams that they haven't used Haskell, I guess, but they've used other things. But kind of then just doing it for fun myself. So I haven't really competed in any physical contest using this.
So I can add that once I participated in the ICCP context at the national level, of course. I didn't get much
Right, yeah.
But at the national level, they didn't allow me to use Haskell, which is
no, they don't. Yeah, exactly.
I wanted to. I had just learned it at the time, and I was this is going to be fun.
Yeah, indeed.
We should convince them.
Yeah, exactly. We should.
Hi. Can you share also the scripts that you use to submit things?
Oh, that's a good question. I can. Is that?
Maybe in a
I can post. I think they're not online, but I can post them.
Right. Thank you.
I can do that. They're written in Python, sadly, but.
Alex.
Not for long.
So usually in competitive programming, I've read and from people that all problems fall into a finite small set of problem categories. Like there's 5 types of competitive problem. And I'm curious, in your experience, are there any types? So we've seen some types where Haskell, with this interact function, makes it a breeze. I imagine there are some types where Haskell actually makes it difficult to find for example, graph problems. I can imagine laziness probably gets in the way or something. Yeah. So how would you classify those?
Yeah,
problems?
that's a good question. Graph problems. I do have. I mean, if you are allowed to, so there's some contests where you're kind of allowed to use any code that you have. You can just copy paste and use it. And there's some problems where you have to type everything from scratch, right? For contests where you're allowed to use code code libraries that you've developed beforehand. I do have some libraries in Haskell that for doing graph search and stuff like that, which is not the code for that is very long, and it uses the ST monad and all that kinds of stuff. But then it exposes a nice functional interface. So, but I would never use that if I had to type it all from scratch, right? There's other types of problems. So, kind of data structure problems where you really need to use mutability to get it to be efficient and stuff like that. Those are really annoying to do. And I would say also, you said, problems all fall into 5. It is a finite number of categories, but the number of categories is much higher than 5. It's like 500 or something. Haskell is, so I think I've solved about 2,500 problems on this site. 1,700 of those I've solved in Haskell. Some of the ones that I didn't solve in Haskell, some of them were from many years ago when I wasn't really using Haskell for this. And some of them are just I don't know of a nice way to do this in Haskell. I fall back to using Java or something. And partly I think that's a failure of imagination, and maybe just when I first learned this kind of stuff, I learned it in an imperative language, and so that's still kind of what I fall back to when I'm doing sort of more complex algorithms and data structures and stuff. And I think there is a cool opportunity to think of, and I've spent some time thinking about this and posting on my blog, but how do we write some ugly Haskell code that's very efficient, but then can expose a nice pure functional interface on the top, and then be able to use that for doing things like this? Yeah.
I have a question. So, have you used competitive programming in education for students?
Yeah.
What's your experience with that?
Yeah, for sure. I mean, I coach the competitive programming team at my school. And I'll often, when I teach algorithms, for example, I'll give them, they can either do an exam or they can solve a bunch of these problems.
Oh, wow.
And so students definitely enjoy it. It's a great vehicle for learning, because it's like very constrained, and you've got to figure out some particular concept or something in order to solve this problem. And so it's a really great way to learn new concepts.
Cool. Someone had a question?
Yeah, so again, about parser combinators, I just noticed the Parsec library is one of the allowed modules.
Yes, I think Parsec is in the judging environment.
Yeah, so why did you decide not to build on top of that?
Yeah, because to use Parsec, there's like 6 imports you need, but there's just enough sort of boilerplate overhead that it's annoying, and I can never remember exactly like what the right incantations are to like make a lexer and then like extract the different lexers from the. So I will definitely use Parsec. There are some problems where a big part of the problem is there's some complicated parsing you have to do. And I will definitely reach for Parsec for those. But for the vast majority of problems, that's a very restricted subset of parsing that you need. And so I just made this simple little scanner library that works.
But you could have made your copy-paste code based on Parsec.
Yeah, I could. But even so, there's still, you have to worry about lexing and stuff. Like the little scanner library that I have, it just splits things on where it just assumes that tokens are space separated, and that's it, right? I just don't want to have to even think about that most of the time, right? Yep.
So one last question.
So this looks like a lot of fun, but is there a chillax version of this where there's like no time pressure? Because to me, that's what sours it. Like,
absolutely.
I would spend the first couple minutes just frantically.
Yeah. No, for sure. No, and in some sense, I agree with you. Like, I do sometimes enjoy doing this with time pressure, but the vast majority of those problems that I said I've solved, like I said, I would call it recreational competitive programming, where the point is not to do it really fast, but just you have a problem and you take as long as you want to try to figure out how to solve it. And so maybe if you think of it competitively, it's more like competing to see who can solve the most problems total over a long period of time, not like, yeah. So yeah, for sure, that is fun, yeah.
So that exists as well.
Yeah, so if you go to just open.caddis.com, there's this site that the contest was on. It's got thousands of problems, and you can just log in and solve them, and it's not part of a contest.
Thanks.
Cool. Let's thank the speaker again. Okay. As I said before, we have a second talk this morning. Does anyone need a toilet break? Okay. Good. Then let's get connected. There'll be like 2-3 minutes.
I will bring them back as well after I change the batteries.